Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. We are in the chapter of inverse trigonometry and we have already introduced the inverse trigonometric functions in our first video. We have seen how to draw the graphs of inverse trigonometric functions in our second video, and in our third video in this particular chapter, in our third topic, we are going to see important properties of inverse trigonometric functions. There are lots and lots of formulae that we are going to use in this particular chapter. So out of these formulae or out of these properties, in today's video we will see what is sine inverse of sine theta, similarly cos inverse of cos theta, etc. Then we will see what is cot inverse x, what is sine of sine inverse x, cos of cos inverse x, etc. And please observe one thing, these two are not same, they are different. We will see how they are different also. Next we'll see the next property, what is secant inverse of minus x, cos inverse of minus x, sine inverse of minus x, etc. And finally we'll see some of the problems. We'll solve some of the problems based on it. Okay, so that is what we are going to discuss in today's video. And if you are new to this channel, don't forget to subscribe it, and if you have understood what's been taught in this particular video, then certainly like this and share it to your friends too. Fine, let us continue with this topic, the first property of inverse trigonometric function. I call it as theorem 1. So what does it contains? All these must be remembered and must be by hearted. Okay now, so what is the first thing? Remember that sine of sine inverse x is always equal to x. When means if x is the domain, x contains the values of the domain of sine inverse x, or simply to say x contains all those values in the domain of sine inverse x. Okay, now what is the domain of sine inverse x? Minus 1 to plus 1. We have discussed this already in the first video. So this is true only when x belongs to minus 1 to plus 1. Minus 1 to plus 1. Similarly, cos of cos inverse x is equal to x. Cos and cos inverse will be ignored. We will write only x. When we will write it again, if x belongs to the domain of the cos inverse x, and what is the domain of cos inverse x? X belongs to minus 1 comma 1 also. Again, okay, now this domain and range of inverse trigonometric functions are very, very important. Keep this in mind. Next, tan of tan inverse x will always be equal to x. When it is always equal to x, again when x is in the domain of tan inverse x. And what is the domain of tan inverse x? You should have remember this, x belongs to R. Similarly, cot of cot inverse x is equal to x. When it is equal to x, again when x belongs to any real number R, because the domain of cot inverse x is x belongs to R. Finally, secant inverse x is again equal to x when if x belongs to the domain of secant inverse x. What is the domain of secant inverse x? Minus infinity comma minus 1 union 1 comma infinity. And finally, cosec inverse x is equal to x. Again same in the domain of cosec inverse x. When x belongs to the domain of cosec inverse x, minus infinity comma minus 1 union 1 comma infinity. This is very easy to remember. Sine of sine inverse x is equal to x, cos of cos inverse x is equal to x, and so on, whenever x is in the domain of the inner functions. You got it? So this is easy to remember. If you know what is the domain of inverse trigonometric functions, it's very, very easy to remember theorem 1. Some basic applications. What is it? Sine of sine inverse 0.5 is equal to 0.5. Because sine inverse of 0.5 is defined, correct or not? But remember, if someone asks you what is sine of sine inverse 5, the answer is not defined. What is the reason that the answer is not defined? Because 5 is not in the domain of sine inverse x. You got it? 5 is not in the domain of sine inverse x. This value must be between minus 1 to plus 1. I mean from minus 1 to plus 1. You got it? Here the answer is not defined. Please understand the difference. So whenever they are asking something, don't blindly write the answer. Sine of sine inverse of x will be equal to x when x is in the domain of sine inverse x. Keep this in mind. You got it? So this is easy. Now let us see the next one under theorem 1. Theorem 2, not theorem 1, theorem 2. So what is it? Sine inverse of sine theta. Please observe one thing. Theta means we generally consider it as angles. X means we generally consider it as numbers. Like, of course, angles are also real numbers only, but keep this in mind. Theta means angle, X means number. Okay, now. So sine inverse of sine theta. Don't think that the answer is always equal to theta. No. Changes will be there. Sometimes the answer is pi minus theta, sometimes it is pi plus theta, sometimes it is 2 pi minus theta. All those things will be detailedly discussed later. You got it? But as of now, when can I say that sine inverse of sine theta is equal to theta? Means only when theta is in the restricted domain of sine theta. When theta is in the restricted domain of sine theta. In video 1, in the first video of this chapter, we have discussed about restricted domains already. For sine theta, the restricted domain theta is what? If theta belongs to minus pi by 2 comma plus pi by 2. If theta belongs to minus pi by 2 comma plus pi by 2. So sine inverse of sine theta is equal to theta only when theta is in the restricted domain of sine theta. Keep this in mind. Okay, now if theta is not in the restricted domain, if theta is not from between minus pi by 2 comma pi by 2 means answer will be some other answer. I will discuss using a problem. I will discuss how and what will be the answers and all. For now, sine inverse of sine theta is equal to theta only when theta is in the restricted domain of sine theta. Similarly, cos inverse of cos theta will be equal to theta. When it will be equal to theta? If and only if theta is in the restricted domain of cos theta now. What is the restricted domain of cos theta? Theta belongs to close bracket 0 comma pi. Got it? Similarly, now I think you all can answer the remaining. What is tan inverse of tan theta? It will be theta if and only if theta belongs to the restricted domain of tan. What is the restricted domain of tan theta? It is nothing but between minus pi by 2 comma pi by 2. If theta is a angle between minus 90 and plus 90, then tan inverse of tan theta is equal to theta. You might be asking, sir, what if theta is not between minus 90 and plus 90? First of all, I will discuss it in the problems. You got it? Later, in some other video, we will discuss it detailedly using the graphs. Next, cot inverse of cot theta is again equal to theta when, if and only if theta is in the restricted domain of cot theta. What is the restricted domain of cos theta? When theta is between 0 and pi. Next, secant inverse of sec theta is again equal to theta. When it is equal to theta, if and only if theta belongs to, what is the restricted domain of sec theta? It's very easy to remember if you have learned the concept from video 1. So the restricted domain of sec theta looks like that of its reciprocal cos theta. Like this. What is it? Theta belongs to 0 to pi except pi by 2. Because if theta is pi by 2, sec theta is not defined. Similarly, cosec inverse of cosec theta is equal to theta if and only if theta belongs to the restricted domain of cosec theta. And restricted domain of cosec theta looks like its reciprocal sin theta. Looks like this. So what is it? Between minus pi by 2 comma pi by 2 except 0. Except 0. So if theta is an angle between these two, then I can say that sin inverse of sin theta is theta. If not, then what is the answer? Means that we will discuss now in the problems. What if theta is not between minus 90 and plus 90? And detail you will discuss it using the graphs. If you use graphs, it becomes even easier. We will discuss that particular concept in some other video. You got it? Now let us see some problems based on these theorems. Just few problems. Okay, I'll explain some problems until you get clarity, and then I'll give you few more questions which you can try at home. What is sin inverse of sin 2 pi by 3? Use theorem 2. First of all, the answer is not 2 pi by 3. The answer is not at all 2 pi by 3. Why the answer is not 2 pi by 3? Because 2 pi by 3 is not in the restricted domain of sine theta. Certainly the answer is not 2 pi by 3. Then what is the answer? So what are we supposed to do is, first of all, I should convert this angle in such a way that the angle is in the restricted domain of sine theta. That means finally this angle which is present here must be between minus 90 and plus 90. So what are we going to do? Very simple. So sine inverse of this sine 120 degrees. Sine 120 degrees is going to be 180 minus 60. 120 degrees is 180 minus 60. And 180 minus theta is in second quadrant. We know that in second quadrant sine is positive. And of course sine remains sine because 180 is even multiple of 90. So sine will be sine only 60. Over. Now 60 degrees means pi by 3. This angle 60 degrees is present between minus pi by 2 comma plus pi by 2. It is between minus 90 and plus 90. Now 60 degrees is between minus 90 and plus 90. Correct or not? So then we can say that the answer is what? 60 degrees. 60 degrees means pi by 3. So what is the answer? Sine inverse of sine 2 pi by 3 is not 2 pi by 3. It is actually pi by 3. Let us discuss more examples to have a clarity. Our second example, what is tan inverse of tan 3 pi by 4? Once again, the answer is not 3 pi by 4. Please understand this. The answer is not 3 pi by 4. Then why it is not 3 pi by 4 means 3 pi by 4, it doesn't belong to the restricted domain of tan theta. What is the restricted domain of tan theta? Minus pi by 2 to plus pi by 2 with open brackets. So 3 pi by 4 means 135 degrees. It is not present in this interval between minus 90 and plus 90. So 135 is not present between these two angles. So that means I should convert that angle as an angle between minus 90 and plus 90. And then I can write the answer. So what is it? As we did in the first example, it is tan inverse of tan 135 degrees. Correct? Pi is 180. So 3 into 180 by 4, you will get 135 degrees. So tan inverse of tan 135 is 180 degrees minus 45 degrees. You can also write it as 90 plus 45. Okay, anyhow 180 minus theta, it is an angle in second quadrant angle. In second quadrant, tan is negative and 180 is 92, sir. Even multiple of 90. Even multiple of 90 means tan will be tan. Odd multiple of 90 means tan becomes cot. All these basics are very much clear for you, I hope. So minus tan theta. So tan of 180 minus theta is minus tan theta. Now don't say that the angle is 45 or minus 45 blindly. Just wait patiently. So tan inverse of and minus tan theta, we know that minus tan theta is equal to tan of minus theta, right? So therefore minus tan theta means tan of minus theta. Now this angle minus 45 degrees is present in the restricted domain of tan theta, correct or not? It is present between minus 90 and plus 90. Minus 45 is an angle between minus 90 and plus 90. So now we can ignore tan inverse and tan, and I can write the answer as what? Minus 45 degrees, which means minus pi by 4. Here I want to give you one clarity. What does it mean? Some students might say, sir, minus tan theta is equal to tan of minus theta. It is okay. Why didn't take tan of pi minus theta? Some of them might think minus tan theta is also equal to tan of pi minus theta. Then why you did not write here in this step, this decision making step? In this step, why didn't you write tan of pi minus 45? That means 180 minus 45. Why you didn't write? They might think. Again 180 minus 45 means what? 135 is not present in the restricted domain. If you write 180 minus 45, again you will get 135, which is not in the restricted domain. Okay, now keep this in mind. My purpose while solving the problem is to convert this angle which is not in the restricted domain of tan. So I'm converting that particular angle into another angle which is in the restricted domain of tan. Before it was not between minus 90 and plus 90. I did something to make sure that now it is between minus 90 and plus 90. This process will be clear for you if you solve 2 or 3 more examples. You got it? I'll give one more example, and after that you can solve the remaining examples which I'll give you. And all the questions that I'm collecting is from NCERT textbook itself. What is cos inverse of cos 13 pi by 6? So first of all, 13 pi by 6, that means what? 13 into pi by 6 is 30 degrees now, which is 390 degrees. 390 degrees is, it doesn't belong to the restricted domain of cos theta. What is the restricted domain of cos theta? 0 to pi, that means 0 to 180, between 0 to 180. So 390 degrees is not an angle between 0 and 180. So I should convert cos 390 as cos of something, some angle. See, 390 is not in the restricted domain. I should convert it into an angle which is in the restricted domain of cos theta. Okay, now what I will do? Very simple. So it is cos inverse of cos 390 means 360 plus 30. Okay, you can also write it as 450 minus 60, but this is better. And I hope all of you know that 360 plus theta is an angle in first quadrant. It is an angle in first quadrant. Cos is positive. Cos is positive, and moreover 360 is 94, sir. Even multiple of 90. So cos will remain cos. If it is odd multiple of 90, cos becomes sine. Okay now. So cos 360 plus theta is cos theta. That means cos 30 degrees. Now 30 degrees is, it belongs to the restricted domain of cos theta. That means between 0 and pi. Between 0 and 180. Therefore, now cos inverse and cos can be ignored. What is the answer? 30 degrees, which means pi by 6. Therefore, the answer for this is pi by 6. Pi by 6. Okay, I'll write some questions on the board. You try to solve it. You got it? And you can comment in the comment sections whether you have got correct answers or not. Take it as an exercise. Here are some questions that I have picked from your NCERT textbook. Try these questions. Okay, try these questions and comment in the comment sections of what answers, the answers that you have got. Just comment it once. Okay, I'll say whether it is correct or not. Fine. The next theorem, we are getting into the next theorem. It is about sine inverse of minus x, cos inverse of minus x, etc. Theorem 3. In that, the first one. So what is the first one? Sine inverse of minus x. What is sine inverse of minus x? Number 2. Cos inverse of minus x. Number 3. Tan inverse of minus x. Number 4. Cot inverse of minus x. Number 5. Secant inverse of minus x. And number 6. Cosec inverse of minus x. Inverse trigonometric ratios of minus x. Okay now, so that is theorem 3. See, it's very easy to by heart. Generally children might be confused. You got it? What will be the result of this? But it is not a point of confusion because it's very easy to by heart. How to by heart? If you observe carefully, when I write it itself, you will understand. When I write it itself, you will understand. So first thing is, sine inverse of minus x is minus sine inverse x. That means simply minus will come out of it. Sine inverse of minus x is minus sine inverse x. Okay now. Next, tan inverse of minus x is minus tan inverse x. And then cosecant inverse of minus x. Cosecant inverse of minus x is also minus cosecant inverse of x. What is the actual reason? You will understand it in proofs. Even here also you will understand it easily. What is it? Remember, sine inverse of minus x is equal to minus sine inverse x if and only if x belongs to it's not x belongs to, it is about angle. So if and only if theta belongs to minus pi by 2 comma plus pi by 2. You might be asking, sir, what is theta here? What is theta? If you take sin inverse of minus x is equal to theta. You got it, where sin inverse of minus x is theta. Okay na? So where theta belongs to minus pi by 2 comma pi by 2. Similarly, if you take tan inverse of minus x is equal to theta, then here also theta belongs to, the theta must be between minus pi by 2 comma plus pi by 2. Similarly, if you take cosecant inverse of minus x as theta, then the theta belongs to minus pi by 2 comma plus pi by 2 with closed interval except 0. Are you observing one similarity here? So wherever theta is between minus 90 and plus 90, okay na? So under the domains, under the ranges of sin inverse of minus x, okay na? Actually sin inverse of minus x is theta, okay na? So under the range of sin inverse of minus x, if it is between minus pi by 2 comma plus pi by 2, for which inverse trigonometric functions the range is between minus 90 and plus 90, it is for sin inverse of minus x, tan inverse of minus x and cosec inverse of minus x. For them only minus will come. And for the remaining three, for cos inverse of minus x, cot inverse of minus x and secant inverse of minus x, okay, what is cos inverse of minus x means pi minus cos inverse x. And what is cot inverse of minus x means pi minus cot inverse of x. And what is secant inverse of minus x means pi minus secant inverse of x. And what is the reason means here theta belongs to 0 to pi. Theta belongs to the range of cos inverse of minus x, which is 0 to pi. Similarly here, what is the range of cot inverse of minus x or cot inverse of x? Everything is same. Theta belongs to open bracket 0 to pi. And here secant inverse of minus x range is also between 0 to pi, from 0 to pi except pi by 2. So are you observing that similarity? Wherever theta is between minus pi by 2 and plus pi by 2, what happened means I got only minus. And wherever theta is between 0 to pi, I got pi minus. Is it easy to remember? I hope you understand this. It's very easy to remember. You got it? And this is the reason why we will get pi minus for these three. And this is the reason why we get only minus for these three. And you will understand that in the proof. Now I am going to give you the proof of theorem 3. See, I'll tell you once again. Always keep this in mind. Anyone can remember the formula and they might solve mains model questions. But if you want to be successful, if you want yourself to be trained in such a way that you can solve any kind of question from inverse trigonometry, means you have to be stronger in concepts. You have to understand why sin inverse of minus x is minus sin inverse x, why it is not pi minus sin inverse x. You should know it. To know that, you should know its proof. Proof is always useful. I'm repeatedly saying, by learning the proofs, you are learning a method of solving a problem. Keep this in mind. So it will make you better in solving problems in case if you know the proof. So let us get into the proofs of these theorems. I'm not going to prove everything. I'll pick any two. Let me prove the fifth one and sixth one. And also one more out of this if needed. Remaining you can prove it. So let me prove the fifth and sixth. Okay, let us see how to prove cosec inverse of minus x is equal to minus cosec inverse x. For this proof, let cosec inverse of minus x is equal to theta. You might be thinking in the previous theorem 3 when I listed the formula, what is theta? Theta means the given question itself. Okay, na? So let cosec inverse of minus x is equal to theta. So first of all, remember that this minus x should be in the domain of cosecant inverse function. What is the domain of cosec inverse function? You know very well. Minus x belongs to minus infinity comma minus 1 union 1 comma infinity. Minus x belongs to minus infinity comma minus 1 union 1 comma infinity. Since, okay, and then theta will be in the range of cosecant inverse function. What is the range of cosecant inverse function? It will be between minus pi by 2 comma plus pi by 2 except 0. Okay, now keep this. These two are very, very important. First we should know this. What is the domain and what is the range? I wrote it. This is the domain of cosecant inverse function and this is the range of cosecant inverse function. Next, I am going to use theorem 2. I am going to use, theorem 1. You got it? Actually, what is theorem 1 says? If I apply cosec on both sides, cosec of cosec inverse minus x is equal to cosec theta. I have applied. Then according to theorem 1, cosec of cosec inverse minus x is equal to minus x. Why means? Because minus x is in the domain of cosec inverse x. Cosecant inverse function. You got it? Minus x is equal to cosec theta. But generally, when I am solving the problems, I will not say like this. Simply instead of applying cosec theta on both sides and using theorem 1, directly I'll make it simple for you. Instead of doing it in 2 steps, what I am going to say is, since minus x is in the domain of cosec inverse function, I will write minus x is equal to what? Cosec theta. I will make it simple. Like cosec inverse goes that side cosec, something like that. You got it? Actually what's happening means we are using theorem 1. I have applied cosec on both sides, then I have ignored cosec and cosec inverse. But instead of saying like that, I am making it simple. Minus x is in the domain of cosec inverse, therefore cosec inverse will go that side. If minus x is not in the domain of cosec inverse means, then cosec inverse will not go that side. Okay, now keep this in mind. We will use it repeatedly. Got it? So then x is equal to, I multiplied with minus on both sides, minus cosec theta. X is equal to minus cosec theta. Now the next step is the decision making step. The next step is the decision making step. You got it? So x is equal to minus cosec theta. Please keep this in mind. Let us come back to the quadrants. If it is a first degree angle, first quadrant angle, take it as theta. If it is second quadrant angle, take it as pi minus theta. Okay, now here I am going clockwise, anti-clockwise. Next, if it is fourth degree angle, take minus theta. And if it is fourth quadrant angle, take minus theta. And if it is third quadrant angle, take it as theta minus pi. In these proofs, you got it? Slowly you will understand in inverse trigonometry why we are doing like this. Here minus theta and theta minus pi are taken clockwise. Okay, now that's why they are negative angles. In these proofs, just take it like this. Slowly you will understand why all these things are happening. Okay, now so first quadrant, second quadrant, third quadrant. This is fourth quadrant and this is third quadrant. So minus cosec theta. In our trigonometry, we have already learnt minus cosec theta can be written in 2 ways. I can write it as cosecant of minus theta, or I can write it as cosecant of theta minus pi. Cosecant of theta minus pi. There are 2 ways of writing it. I can write minus cosec theta as this or this. Which one to choose? Please observe here. This is the decision making step. Come here. If theta is between minus 90 and plus 90, then minus theta is between which 2 values? If theta is between minus 90 and plus 90, when I multiply with minus everywhere, what happens? Minus into minus pi by 2 plus pi by 2, that will come here. Minus into minus plus pi by 2 will come here. Okay, now then minus theta as it is, and minus into pi by 2 minus pi by 2, it will come here. You should know the basics of inequalities for this, but it is easy to understand. If theta is between minus pi by 2 and plus pi by 2, then minus theta is also between minus pi by 2 and plus pi by 2. Instead of writing like this, I am writing it directly. What I am doing it here, if theta belongs to minus pi by 2 comma plus pi by 2, then minus theta also belongs to minus pi by 2 comma plus pi by 2, except minus 0. Except minus 0 means except 0 only. Now my question is minus theta present in the restricted domain of cosec theta or not? Is minus theta present in the restricted domain of cosec theta or not? Of course, minus theta is also between minus 90 and plus 90. It is in the restricted domain. So I am choosing this. Minus theta is in the restricted domain of cosec theta. What about theta minus pi? Is it in the restricted domain of the cosec theta or not? You can check it. Theta belongs to minus 90 and plus 90 means theta is between minus 90 and plus 90. Theta minus pi means we are subtracting pi, na? Subtract pi. Minus pi by 2 minus pi less than or equal to theta minus pi less than or equal to pi by 2 minus pi. That means theta minus pi is between minus 3 pi by 2 and minus pi by 2. Observe one thing, theta minus pi is between minus 3 pi by 2 and minus pi by 2. This is not in restricted domain of cosec theta. So this is in restricted domain of cosec theta. That is the reason why I am writing minus cosec theta as cosecant of minus theta. And this is not in the restricted domain of cosec theta. That is why I am not writing, I am not taking this. Okay na? So therefore minus cosec theta is taken as cosecant of minus theta. I am not choosing this. You have to understand this. If you do not understand this now, certainly you will understand it in next proof. You don't have to. Have some patience. You will understand all these things slowly. In case if you do not understand, once again rewind once and cross check it. You will understand certainly. So minus of cosec theta is equal to cosecant of minus theta. Now minus theta is in restricted domain of cosec theta. Since minus theta is in the restricted domain of cosec theta, cosec will fly this side. What happens? Cosec inverse x is equal to minus theta. But actually what's happening means I will apply cosec inverse on both sides and then I will use theorem number 2. That is what actually is happening. But instead of using theorem number 2, I'm saying this directly. Cosec is flying to the left side and becomes cosec inverse only because minus theta is in the restricted domain of cosec theta. If minus theta is not in restricted domain means this cannot fly. Okay na? Okay, fine. Cosec inverse of x is equal to minus, what is theta here? Theta is cosec inverse of minus x. So multiply with minus on both sides, you got your proof. Therefore cosec inverse of minus x is equal to minus cosecant inverse of x. We will also see how to prove that secant inverse of minus x is equal to pi minus secant inverse of x. Secant inverse of minus x is equal to pi minus secant inverse of x. Now let us see how. Okay na? Very easy. We'll start. We'll let secant inverse of minus x is equal to theta, just like the previous proof. Okay now minus x, I will, where minus x belongs to the domain of secant inverse function. What is the domain of secant inverse function? Minus infinity comma minus 1 union 1 comma infinity. Then if minus x is in the domain of secant inverse, then theta will be in the range of secant inverse. What is range of secant inverse function? Theta belongs to the range of secant inverse function. I hope all of you remember it. What is it? 0 comma pi except pi by 2. You got it? This person will be responsible to get pi minus at the end. Okay now this person 0 to pi. See how. So first of all, my question is, can I write that minus x is equal to sec theta is secant inverse? Can secant inverse fly to the right side and become secant? Yes, of course. How means theorem number 1. What's actually happening? I will apply secant on both sides and I'll write this step. But I'm skipping it. I'm just directly saying this. See, minus x is in the domain of secant inverse. Therefore, secant inverse will go to the right side. Okay now, next x is equal to, multiply with minus on both sides, x is equal to minus sec theta. X is equal to minus sec theta. Next, now the next step is the decision making step. Next step is the decision making step. Come back to this. First quadrant angle theta, second quadrant angle pi minus theta, fourth quadrant angle is minus theta, and third quadrant angle is theta minus pi. Where is secant theta negative? Secant theta is, where is secant theta negative? Secant theta is negative in the third quadrant or second quadrant, correct or not? Secant theta is negative in third quadrant or second quadrant. Therefore, I can write minus secant theta as secant of pi minus theta or secant of theta minus pi. In these two, one is correct. Who should be taken? The angle which is in the restricted domain of secant, he will be taken. The other will be ignored. Okay, now. So I hope now you are getting a clarity. Okay, first of all, theta is between 0 and pi. Na? Let us check whether pi minus theta is in the restricted domain of sec or not. So theta is between 0 and pi. Then minus theta is between minus 0 will come here and minus pi will come here. We have to interchange those values when I multiply with minus. Next, it is not only minus theta, it is pi minus theta. That means I should add pi now. Add pi. Pi added here, pi added here, pi added here. So what is it? 0. Pi minus theta is between 0 and pi. Pi minus theta is between 0 and pi means what? Once again, pi minus theta is in the restricted domain. It is in the restricted domain of secant theta. It is. So pi minus theta is in restricted domain of secant theta. Therefore, we have to consider secant of pi minus theta. If you want to check whether theta minus pi is in the restricted domain of secant or not, like this method, you will understand that it is not in the restricted domain of secant function. It is not in. Theta minus pi is not in the restricted domain of secant. Pi minus theta is in the restricted domain of secant. So that's why I am choosing secant of pi minus theta. I am not choosing secant of theta minus pi. So therefore, final conclusion is what? I am taking minus sec theta as what? I am taking minus sec theta as what? Secant of pi minus theta. Now pi minus theta is in the restricted domain of secant function. Secant function means what? So secant function, you know. That's why secant is ready to fly to the left side. If this is not in the restricted domain of secant means secant cannot fly to the left side. Got it? So now secant is ready to fly. Secant inverse x is equal to pi minus theta. Secant inverse x is equal to pi minus. So what is theta here? Theta is what? This secant inverse of minus x. And take minus secant inverse x. Take this left side and take it that side. So secant inverse of minus x is equal to pi minus secant inverse of x. You got it? So I have proved 2 properties out of the 6. You try the remaining, certainly you will get the answer. There is no doubt in that. The decision making step is this. How I have proved cosecant inverse of minus x is equal to minus cosecant inverse of x. In same way, you can prove that sin inverse of minus x is equal to minus sin inverse of x. Tan inverse of minus x is equal to minus tan inverse of x. The same way. Similarly, if you understand this proof of secant inverse of minus x, you will automatically prove what is cos inverse of minus x and cot inverse of minus x. You will automatically prove it. You got it? So you solve it and you let me know in the comment sections whether you have got the proofs of the remaining or not. You got it? And finally, how do we use it in the problems? That's very, very simple. And once again, how to remember it? I'm just giving you a clarity. How to remember it? Sin inverse of minus x, then tan inverse of minus x, and then cosecant inverse of minus x. All are equal to what? Sin inverse of minus x is minus tan inverse x, tan inverse of minus x minus tan inverse x, and here minus cosecant inverse x. What is the reason means? Because for all this theta is between minus pi by 2 and plus pi by 2. Okay, now actually to be precise, for the first one, theta is between minus 90 and plus 90. For the second one, theta is between minus 90 and plus 90 with open brackets. And for the third one, theta is from minus 90 and plus 90 except 0. Look at the ranges. Because of these reasons, here only minus will come. And cos inverse of minus x is pi minus cos inverse x. Then cot inverse of minus x is pi minus cot inverse x. And finally sec inverse of minus x is equal to pi minus sec inverse x. Why? What is the reason? Because for these three, theta is from 0 to pi here, theta is between 0 to pi here, and theta is from 0 to pi except pi by 2. If the ranges are between 0 to pi, I will get pi minus. If the ranges are between minus 90 and plus 90, I will get only minus. Is it easy to remember? Yes, it is easy to remember. How do we use it? Very, very simple. It's very easy to use. What is it? We can say that sin inverse of minus 0.5 is equal to minus sin inverse of 0.5. That means what? Minus sin inverse of 1 by 2. And I hope all of you know what is sin inverse of 1 by 2. It is pi by 6. So the answer is minus pi by 6. What is cos inverse of minus root 3 by 2? It is pi minus cos inverse of root 3 by 2. That means pi minus cos inverse of root 3 by 2 is pi by 6. So pi minus pi by 6 is 5 pi by 6. We can use like this. Next, what is cosec inverse of 2 by root 3 with minus sign here? What is cosec inverse of minus 2 by root 3? It is nothing but minus cosecant inverse of 2 by root 3. Minus as it is, and cosecant inverse of 2 by root 3 is same as sin inverse of root 3 by 2, which is nothing but pi by 3. So the answer is minus pi by 3. I hope it's easy to understand. So these problems are done using theorem number 3. Okay, so in the next class we will see few more properties. Many properties are there. See, I am telling you how to prove it, and at the same time I am telling you how to remember it. How to remember, this is very important. We should know how to remember it so that we can solve the problems quickly, and most importantly we have to understand the proofs. That's where your concepts become stronger. That's where your ability to solve advanced model questions become lot and lot better. So dear students, don't run behind solving too many problems always. Of course we have to solve too many problems, but when? First of all, we have to be perfect in concepts. So you want to be perfect in concepts, then watch all these videos and be perfect in it. And if you have understood this concept, like the video, subscribe the channel, and do refer it to your friends. We'll continue in next part. Thank you.